Good day. My name is Latani Modao, and my student number is 184-689-34. Today I will be presenting my project, which is titled Secure Electronic Voting Machine with Blockchain Verification. The aim of this project is to develop an electronic voting system that allows a voter to enter their identification number, select a candidate, and record their vote electronically. The system uses an ESP32 microcontroller as the main controller. It allows, or it also uses an OLED display, the keypad, buzzer, and status indicators. The voting records are protected using the SHA-256 cryptographic hashing, where each voting record is linked to the previous record to create a blockchain style verification system. I will now explain the components and demonstrate how the system operates. Right now I will be demonstrating all the common components that we use for connecting this machine, the secure electronic voting machine. So here we're gonna start with the wires. These are the wires that we use to wire the system. I'm gonna put it aside, and then we have the signal lights, LED, in different colors. We have green, yellow, and red. I'm gonna put it aside. We have now the power source, battery terminal. So I will be using the AAA batteries. And now we have the beeper or the buzzer. It makes sounds if you make error putting in your ID. I'm gonna put it aside. We have now this system where you put your fingerprint if you will be voting using the fingerprint, and then automatically the system will read your ID via the fingerprint. Not necessary that you will be having to punch in your ID manually. So this is the system that you will be using. And now we have the the keypad or the keyboard. So this is the one that you punch in if this fingerprint system it's not working, or if your fingers are not registering, then you punch it manually. You punch in your 13-digit ID. This is the breadboard that we make all the connections around, and then this is the OLED, the screen display. This is where your ID will be displaying. This is where it will also be displaying if the access is denied when you put in your ID. Alright, as I'm connecting my system now, you will see that I've connected my breadboard already. So I'm just gonna put in together my keypad, and this is my OLED. It's connected, as you can see. So on this system, I'm going now to add the power source. which will be my battery. I'm just gonna put it on this other side. I've got my positive and my negative. So I will link into the breadboard, and then I will also connect my positive. So now we're gonna go to connect the LED. This is now my LED. It's gonna reflect all the colors. So I will mount it just somewhere here. This is my LED. I will start with the ground. I will be using this wire for the ground. There it is. And I'll just connect it to the breadboard. And now I will go to there is a name points here on the terminals. If you can see, we have red, we have yellow, and then we have green, which I'm gonna link that to this system, which is the ESP32. So I'm gonna start with the red terminal. There it is. My red terminal will go to the point of the ESP32. I will connect it to number D18. Where is the terminal here? These things are too small to see. Oh, there is my D18. This is my D18. There it is. Now I will connect my yellow wire on the LED. The yellow wire will connect it to the ESP32 on the point terminal D13. Where is it? There is my D13. Hey, these things are too small to connect. Yeah, there we go. I'm just gonna remove the terminal battery for now to avoid the signal coming on and off. I'll just remove the positive wire from the system. All right, I've connected that. Now we're gonna connect the green light to the SCP-13 system, where this one now it's gonna go to D2. Gonna connect it to D2. Where is D2? Oh, there it is. Now that LED is complete and connected, my ground is there, all the lights, colors are there, connected perfectly with ESP13. Now we're gonna connect the fingerprint into the system. My double-sided tape, just to make it neat. I will just try to put it here together to avoid breaking it. So here we have 5 connections that we have to connect together. These are all my wires. I'm gonna start with the ground for easy connection. There it is, my ground. Is this thing tight? Okay, it is. All right, now I'm gonna connect. Come closer. I just want you to show that the terminals on my fingerprint, we have the ground, there it is. We have the SDA, which is this SDA. I will be connecting it to, on my breadboard, to D25. So I'm gonna take that wire here, you can see, and then I will be connecting it here on my D25. And then just come closer. I want to show you now my VDD, which I will also be connecting it to the breadboard on the positive terminal. Can you see closer? Can you come closer? Just okay, there it is. So this is my power cable. It went straight to the positive terminal. Now I will be connecting, come closer here. I want to demonstrate the SCL terminal. This one I'm going to be connecting it to a D26 on my breadboard. This is the wire. It will be going to D26 on my breadboard. So this is D26. There we go. So now we are left with on the system, we are left with what? I think I've connected this one now. It's going to my ESP34. I will be connecting it to D34. These things are quite too small. There it is, D34. And now I will be connecting the buzzer. This will be the last component on the system. This is the buzzer. This is the one that makes sound on the system. This is my buzzer. Okay, I will be connecting this buzzer to this one. Will go to the ground. I think I'll just put it next to the on the breadboard. It goes straight to the ground. All right, now the last wire, I will be connecting it to the D15 from the buzzer. Where is my wire now? Oh, there it is. I'll be connecting it direct from ESP32 on my D13, on my D15 I mean. Where is my D15? Okay, there is my D15. Yes, that's the terminal. There we go. It is connected. So now I'm gonna connect the last wire, which is I've disconnected in the beginning, the battery terminal. And then definitely you will see one of the lights coming on to show that my battery have power. There we go. All right, now the system is connected fully and ready to operate. I will be demonstrating how the system works. So this is me. I am a voter on the voting machine. It is called a secure electronic voting machine with a blockchain verification where the display will be happening. So this is the voter. He or she will be using a fingerprint. You heard the sound that the vote went, the fingerprint is recognized. Now, then the voter will select the candidate. Which one? So now I'm gonna choose option number 1 as a candidate, and then it will show, and then now it will reflect on my, it will reflect here on my storage, where you can see candidate number 1, and then it will also show that this person used a biometric to vote. So now we're gonna go again. We will use the fingerprint a voter. This person will come and vote for different candidate. So we are going for candidate number 2. There it will show, and then we come here on the storage, it will reflect that candidate number 2 has voted, and it's a biometric. So now we are going to vote with a fingerprint, where with a ID, a manual ID, not a fingerprint. So in an event where the fingerprint is not available from a voter. So now I'm gonna demonstrate that. This will be candidate number 3. It's still going. This will be candidate number 3. Oh yes, there is candidate number 3. This person is gonna put in the ID, as you can see on the screen. There is a full 13 digit, and then we press enter, and then this person is choosing what candidate. So we're gonna go with candidate number 3, and then it will reflect on the screen. The candidate number 3, there it is. Candidate number, candidate number 3. And then here is the ID. It's the same ID, if you can check back here on this display screen. And then now we're gonna go to create an error. If now this voter will put an error ID, it will reflect on the LED where you will see a red light coming on. So now we're gonna go in and create error ID. And then we press enter. There is a red light, access denied. So we're gonna verify that with the correct ID. So now we're gonna use the correct ID. The correct ID, there it went through. Now we're gonna select a candidate. This will be a candidate number 4. Then it will come and reflect on the storage, candidate number 4. And then it reflects the ID which was punched on the keypad. So we are going to vote for the last time with a manual ID. So we're gonna continue to vote with the ID. This will be a different ID as well. You can see this ID. It will also reflect after we have as a candidate. It's create error, so we're gonna correct that. So it's going to be 922588584. There is the ID, and then it went through. So now we are choosing the candidate. So it's a candidate number 5, and then it will come and reflect here on the screen. There is candidate number 5, the same ID reflected on the screen. So now we are going to verify on the verification of all these voters. So this is where we will come, then I'm gonna refresh it, and then we can see all the voters on the screen, the blockchain verification. So you can see all the candidates who have voted. You will see we have 3 candidates who voted using the fingerprint, the biometric, and then we also have 3 candidates who voted using the manual ID numbers. And now I will be concluding my project. And in conclusion, I have successfully designed and demonstrate my secure electronic voting machine with a blockchain verification. The ESP32 is the main controller and communicate with the OLED display, the keypad, buzzer, and the status indicator. The voter enters their identification numbers, select a candidate, confirm the vote electronically. The voting record are then protected using the SHA-256 hashing, with each block linked to the previous block. This now allows the system to detect unauthorized changes to stored voting records. The project demonstrates how embedded the system and the blockchain principle. The blockchain principle can be combined to improve the security and integrity of electronic voting. In future, the project can be improved by implementing multiple blockchain nodes, stronger voter authentication, encrypted communications, and a distributed blockchain network. Thank you for watching my demonstration. My name is Latani Modau as a student number 184-68934. Thank you.